Now that we've gotten through this refresher with data sets that are generated so they're a little more normalized, a little more familiar with expected outcomes, let's go back to our class file that's looking at the population and male and female. If you need a reset, this is posted on Moodle. You can just grab that link, or you can pull up your own data set. It's advisable to make sure that you have exactly what is shown here, which is representative of the link, mainly so that when we get to outcomes, answers, and that discussion, everything lines up. So let's move into doing the statistics on this portion, the descriptive statistics, by selecting data, data analysis, descriptive statistics, select OK. We can put in our input range. Columns, label in the first row. Let's give it an output place. I'm just going to put it right here at the top of my page. And select summary statistics. At this point, I assume you're a pro at these quick calculations in Excel. And let's kind of focus on what these outcomes are here. Okay. So if we recall, this here is our X bar, right? Which means that the average state has about 6 million people in it. And we feel that that average is pretty close by about 1 million. So plus or minus 1 million, we're really right in there. The median, so if we listed them from 0 to the max, is around 4 million, right? Now this makes sense here that the mode, there's no state with the exact same population, or no two states that have this exact same population, and that's what we would expect. Our standard deviation here is around 7 million, right? So let's kind of put in our terminology here. Our kurtosis is very, very high. We're going to pay very close attention to that. And our skewness is actually out there as well. So this will come into play a little later on. Our range, right, goes from the max minus the min. So anywhere from around 500,000 people in a state to around 38 million people in a state. And then the total population, right, this is the sum of all the population of the USA, right? The total sum. And then this is our data set value, right? 52. We know there's 50 states, but we also recognize that Puerto Rico and Washington, D.C. are represented in this data set as well. So let's take a look at a couple of items here. I'm going to change some formatting. Make it a little easier to view. So let's change some of these key values to numbers, right? So that they look like numbers we can talk about. I'm going to move over here. If we look at the data set starting with the mean, right? So let's take our X bar and let's add one standard deviation to it. So from a formula perspective, it is equal to the mean plus we'll just kind of sneak one in here real quick. 1 times, not the standard error, the standard deviation. Right? Let's move this so we can see it. So that means that the average of around 6 million plus 1 standard deviation is approximately 13 million. Let's visualize this for a second. So if we have a normal distribution, right, and we say that x bar is right here, and this is x bar, and we say that x bar plus 1 standard deviation, that means that everything over here is approximately, it's really in the 84%, but it's approximately 85% of the data set. Right? So that means this represents a big chunk, right? If we add 2, well, let's say this is 13 million here, right? 13 million. If we had two standard deviations, let's come in here and change our formula to say plus 2. We're going to end up with 20 million. Right? This is 2 standard deviations. So then this part here is around 95%. 95, 96. We'll use some nice round numbers here just for the point that we're trying to make. Let's look at our data over here and take a look at what's happening. We see some strange large numbers here. We see our skewness as a problem. We see our kurtosis as a problem. And if not, if you're not really familiar with these statistics, don't worry. These are very large numbers, and we'll see that again really soon. If you compare these numbers to what you were getting before in your randomly generated data sets, you'll notice there's quite a difference. Let's do some fun stuff here. If you're not a real Excel whiz, go to your data tab and just select right here into your data set somewhere. And there's this filter. Again, your ribbon might look a little different, but it's up there. It might be like a gray color. Select filter, and now we have this great ability to sort. Let's sort our total population from largest to smallest, or from Z to A. Let's take a look at this. There are 4 states that are represented here approximately right here, that are greater than, right, let's say greater than or equal to 20 million. This is kind of an interesting situation because if we round that off, that means that these 4 states are so far out there. They're 2 standard deviations off, and they're beyond that. And so California, being the most populous state, is 38 million. We could even go a little bit further here and add another standard deviation. We get 27 million. So now Texas is 3 standard deviations out. And if we add another standard deviation, we're at 34. So we're at 4 standard deviations, and we haven't caught up to California yet. This presents a very interesting question. If California is more than 4 standard deviations off of the average, of the mean. We have 4 states that are beyond the 85% representation. How do we compare these states with these states? Let's kind of look at our analysis here. Let's actually take away a standard deviation. Let's minus 1 times. This actually represents a negative number. So if I put my, let's use this color here, a nice green one. So if I use my negative standard deviation of -1, it actually isn't here. It's beyond the x-axis. It's over here, or the y-axis. It's over here. Do we have a negative population in any given state? The answer is, of course, no. We don't have negative people. This is a real problem when making recommendations, because recommendations at their heart are a comparative analysis. This is recommended because this is better. This is not recommended because this is worse. What now becomes very desirable is a way of creating common units. Common units is what we would refer to as normalization. We're going to normalize this data, and it's not so much as making it normal in our sense. It's making it normal in the statistics sense, where we can now compare things. It puts it more into this realm here, where we don't have things sticking out over here, and we don't have standard deviations, multiple standard deviations not represented. So how do we create common units? Matter of fact, if you wanted to go through this here and create a histogram, you could go through those steps. Matter of fact, we'll go through them right now. Let's go to data. We're going to go to data analysis. We're going to go to histograms. And we're going to go through this part. Our input is going to be our input is going to be our data population, or total population. Our bin range, oh, not resolved. Okay. Hopefully you were catching up to that before we even got there. Let's give a bin range. And we do our bins by looking at our maximum and our minimum, right? And figuring out how many bars that we want, right? It's the most practical way to start. All right, so let's use, we know that the average is around 6 million. We're starting around 500,000 or million. So let's just go in increments of, say, 2 million. Now, if we're going to do this correctly, remember we have to make it up to 38 million, but we're only at 6. So let's agree that we need to make it up to the 1 standard deviation, which is 85%. Let's come back over here and kind of remind ourselves where it's at. 13 million. So you can continue to key those in. And I'm going to use 2, 4, 6, 8, 10, 12, 14. Let's go to our data analysis, histogram, input range. I'll give you a little secret here. If there's nothing below the data set, you can just select the whole column. Just select on the B. There's several ways to do it. That's just one of them. Just be careful when you do that approach. There's nothing underneath of it. Having a clean data set is really important. Okay. Our bin range, which we agreed on, this right here. And we have labels. Now we're at output options. We're going to put our histogram. Let's just put it kind of right. It's right here below. And we do not want Pareto. We do not want cumulative. We just want the chart output. So let's go ahead and select OK. This histogram is our representative or representation of the data set, right? The normal distribution. So we're seeing this big tail, coming way out here, right? So it's pulled to the right. So it's a very positive skewness. Right? We see that here, very positive. Right? And our kurtosis is actually quite pointy because it's missing this tail over here. It's very tail heavy on this side, but not on the other side. So it's very pointy. So this represents, we should be seeing something like this, but we're missing a whole chunk right here. And you could play with this using lots of different bin range approaches. And the common outcome for something like this is going to be kind of a bimodal option with this big stack at the end, right? Which this is X and Y. And this represents all those pieces that, all those data set points that are greater than, a standard deviation. But we'll save ourselves some time, and we'll kind of get rid of some of this here. So let's talk about normal distribution or normalizing data and what we have available. Let's take a break from this. If you wanted to play with the histogram and see what options you could come up with, great. We'll move to another video just in case you're kind of want to stop for today and come back to it, or for this particular time and come back to it. We'll start at a new video and we'll discuss normalization.